Afternoon, the grade 9 learners. I'm just going to continue with algebraic expressions, algebraic equations. And then with grade 9, I have actually did with grade 8, I actually did the how to set up an equation, of which for grade 9 it will be a baseline. And then again, while I was dealing with setup in the equation, I also infused the how to apply the additive. In fact, firstly, how to solve the equation by inspection, and then I also infuse the method of using the additive and the multiplicative inverse, of which those forms part of grade 8. Now let's go on from this now. I would just like to highlight the issue of exponential equations, as they are also challenged in both grades. Now, for grade 9, I would like you to go through this notes with you. Now let's have a look at the exponential equations. An exponential equation is an equation where the variable you are solving for is in the exponent, or the variable is in the base. Alright, secondly, when solving equations, it is important to note that if b to exponent of x is equals to b to exponent of y, then the value of x will be equals to the value of y. That's one important thing. And then this is known as equating exponents. If the bases are the same, we just equate the exponents and then we solve. And then if the bases are the same, the exponents are equal to each other. Alright, and then the next part that we need to understand, if x to exponent of b is equals to y to exponent of b, then automatically x will be equals to, the value of x will be equals to the value of y. This is known as equating bases. If the exponents are the same, bases are equal to each other. Right. And then this is what we need to bear in mind. Please take note that for this point, if the exponents are even, there will be two solutions. If the exponents are even, there will be two solutions. So we must be careful of that. But if the exponents are odd, then we will have only one solution. So I think for grade 8 and 9, that's where the problem arises, whereby a learner will be writing only one solution for the even exponents. Right. And also take note that the above rule is always true as long as the base does not equal to 0 or does not equal to 1. Because if the base is 0 and the exponent is 0, we are going to have the undefined situation. And if the value of the base is 1, again, remember any 1 to any exponent will remain 1. So we must be careful of this point. Right. Now, solve for x in the following. 1, 3 to exponent of x is equals to 3 squared. Right. As I've actually explained, in this situation, already the bases are the same. So what must we do now? What will be the answer for x? It is clear that the answer for x will be x is equals to 2. Bases are the same, and then therefore x is equals to 2. The value of x is equals to 2. And again, something that I didn't actually explain is that you actually have to substitute to the original equation to check if the left hand side will still be the same as the right hand side. And as you can check, if the value of x is 2, the left hand side is going to be 3 squared, and the right hand side also is going to be 3 squared. So it is true that x will be equals to 2. Now let's take another example or activity. We are also having 2 to exponent of x is equals to 2. All right, now for this one, it brings back the issue of the language in algebraic expressions to say if we are having a number as it is or a variable as it is without actually indicating the exponent, then we know that the exponent is 1. So we must take note of that. So in other words, for us to solve 2 to exponent of x is equals to 2, then take note that 2 must be raised to exponent of, is raised to exponent of 1. Right. Therefore, the same way that we did with this one, because now the bases are the same, then we equate the exponents. So therefore, the value of x will be x is equals to, will be 1. Right. And then this one, it took another level. We can classify it under level, at least under level 2. Right. Because there will be a step that must be done, and then after that, that's whereby we will have to equate the exponents. Now, the tip is, if you are having you have to solve a problem like this, you must ensure that the bases are the same. So it is clear that 25 must be represented as base 5. 25 must be represented as base 5. So if we represent 25 as base 5, now we need to know what will be the exponent of 5 in order, what will 5 be raised to in order to be 25. So that simply means we will be having 5 being raised to exponent 2. Now, because now the bases are now the same, as you can see, now we can equate the exponents. So the exponent on the left hand side is x minus 2, on the right hand side is 2. Therefore, x minus 2 must be equals to 2. Right. Now, we are on the situation whereby we need to solve this equation now as linear equation. So as linear equation, we've got two methods that we can apply. The first one, it is of inspection, whereby we are actually looking for a number in which when we subtract 2 from, it will give us 2. And it is clear that that number will be 4. Right. And then going to the next activity. Right. Now this one is the one in which we have to make the exponents to be the same. And in this activity, we will realize that already x is raised to 3 and 2 is raised to exponent 3. So now we don't have any problem of changing to the same exponents. Already they are on the same exponent. But now we have to look the exponents, whether are they even or are they odd, of which in this case we are having the exponents that are odd. And in this situation, as I have explained earlier, this will be the only, we will have only one solution for the value of x. Right, the solution, exponents are already the same, therefore the value of x will be equals to 2. And again, if you take 2 and substitute, you take this value of x, you substitute it on the original equation, you'll realize that left-hand side becomes, left-hand side is the same as right-hand side. Like for instance, the value of x will be replaced by 2. The left-hand side will be 2 to exponent of 3. And the right-hand side will also be 2 to exponent of 3. Therefore, the equation is balanced. All right, and then the next one, again, it take the higher level than the first one. X squared is equivalent to 16. And now we have to represent 16 by exponent 2. So if we represent 16 by exponent 2, that simply means we'll have to have 4 raised to exponent 2. Right. Now let's have a look at this solution. Yes, x squared will be equivalent to 4 to exponent of 2. Now let's make exponents to be the same. We are having same exponent on left and right hand side. So therefore it is clear now the exponents are even. Because the exponents are even, we are going to have 2 solutions. So the solutions that we are going to have, they will only differ with signs. They will only differ with signs. Right. As you can see here, if we have to check this, both solutions, you will realize that if we substitute x by 4, right, as you substitute x by 4, because we are having, okay, let me, right, if we substitute, because we managed to get x, we managed to get x being equals to, we managed to get x being equals to 4, or x being equals to -4. Now let's substitute and check if right hand side will be the same as left hand side. Now let's take where x is equals to 4, and then we substitute in the original equation. It simply means for x we will have 4 squared, which will be our left hand side, and 4x squared will be equals to 16, which is the same as the right hand side. Right, and then let's have a look at -4 now, where x is equals to -4. Let's start with left hand side. For left hand side, when we substitute, we will have -4 squared. Then -4 squared will give us positive 16, which is the same as right hand side. So that is why I'm saying for the even exponents, we must be careful. The answer, we are going to have two solutions that differ with only signs. The one will be positive and the other one will be negative. Right, now let's continue. Right, now we are going to the solving equation by substitution into algebraic expression. In other words, that is part of the equations. Now let's have a look at this one. Variables in algebraic expressions can have any value. That is why they are referred to as variables. Their values varies. I mean, their values vary. Right. The algebraic expression only has a value once the variables have been assigned their values. They will only have values if the variables are assigned the values. Right. Now let's have a look at this one. Determine the value of a squared plus 2b minus c if a is equals to 3. Right. The solution. It simply means we are going to substitute for a. We are going to substitute a with its value 3. We are going to substitute b with its value -4 and c with -1. Right. I will also encourage that you use the brackets when you substitute in the expression. Always use the brackets because most of the time the answer will be affected with the negative sign. So we better use the brackets. Now let's see what has happened. You will realize that in the place of a, we have just substitute. We have just taken off a and replace it with 3. So it is still a to exponent of 2. It is now represented in its value, right? And then we go to the value of b. We are now having +2 into, remember the brackets represent the multiplication, and then the value of b from the question is -4, and then lastly negative c will be negative in brackets -1. And then we have to simplify now. 3 squared will give us 9, 2 multiplied by -4 will give us 8, and negative times -1 times -1 will give us +1, and ultimately the answer will be 2. So take note that 2 is the value of a squared plus 2b minus c if a is equals to 3, b is equals to -4, and c is equals to -1. That simply means if the values of a changes, so the value of the expression is going to change. Right, let's go to the next activity. Determine the value 2x squared minus 3xy plus y cubed if x is equals to 5 and y is equals to -3. That simply means we are going to substitute x with 5, y with -3. Now let's go straight to the solution. For the solution now, we are having 2 from the expression, and then we also have x squared. So instead of x, we replaced x by 5, and then it's still 2 exponent of 2. We are also having -3 is still there, and then we substitute x with the value 5. We substituted y with the value -3, and then plus you check y, the value of y is -3, and that y is raised to exponent 3, therefore -3 will be raised to exponent 3. Then we just simplify. On simplifying, taking each one step, by taking it step by step, you will realize that 5 squared will be 25, and then negative 3 times 5 will be 15, and then will be negative 15. Then negative 15 multiplied by negative 3 will be positive 45. And then negative 3 raised to 3, it will give us negative 27. And the negative 27 multiplied by positive 1, it will still be negative 27. Right, and then multiplying 25 by 2, it will give us 50. And then 45 minus 27, it will give us 18. Then the final answer will give us 68. That simply means the value 68 is the value of 2x squared minus 3xy plus y cubed if x is equal to 5 and y is equal to negative 3. That is how substituting on expression works. Right, and then this is a bit challenging now. We have actually upped the level, right, but we are still going to do whatever, the same thing that we did in activity 1 and 3. Right, now let's have a look at the solution for this one. Right, the solution here, we have to substitute a by negative 1, b negative 3, and c positive 3. Here we go. We still have 2 as constant, or rather coefficient, and then in place of a we are having negative 1, in place of b that's negative 3 raised to 2 because b is raised to 2 or to exponent of 2, and then c is raised to 3, therefore the value of c will be raised to 3, which is 3 to exponent 3. And then we just simplify. You will realize that on the denominator we are going to have 3 squared, negative 3 squared, which will be positive 9, and then 2 times negative 1, it will give us negative 2. Then for the next step we will have negative 2 times by positive 9, which will give us negative 18. Negative 18. Let me just show this one on the calculation. Right, let's have a look at this, which is part of the solution. We are having negative 2 multiplied by 9 divided by 27. So that simply means it will be equals to, let's simplify. There is a number that divides into 3 and also divides into 27 without leaving a remainder. That number is 3. So in other words, 3 in 9, it will go 3 times, and 3 in, it will go 2 times, and then 3 in 27, it will go 3 times. So therefore the final answer will be negative 4 on 3, or negative 4 divided by 3. That will be the final answer. So we can have a look at the presentation. Right, the answer there will be negative, why negative 2? No, it shouldn't be negative 2, because 3 into 9, it goes 3 into 9, it goes 2 times, and then into 27 it goes 3 times. So 3, no, that is correct. Sorry for the mistake done. Let me go back to this one. Right, let's have a look at this. 3 into 9, it goes 2 times. In fact, it must be 9 into 9. It must be negative 2 multiplied by 9 divided by 27. Right. So we are saying 9 divides into 9 once, and into 27 it divides 3 times. That simply means negative 2 multiplied by 1, it will give us negative 2, and then over 3. Sorry for the inconvenience cost. Right, let's go back to the presentation now. Right, so now we are having negative 2 over 3 as the value of 2ab squared over c cubed if a is equals to negative 1 and b is equals to negative 3 and c is equals to 3. Right. Now we are now going to another objective where we have to use substitution in equations to generate tables of ordered pairs. I know for this one, most of our colleagues, they actually not do it, and it is part of our CAPS. So let's have a look at this. And again, for grade 9, it is just a baseline because it is done in grade 8. Right, so let's have a look at this. When using substitution in equations to generate tables of ordered pairs, we need to note that in the relationship y is equals to 2x minus 1, x is called an independent variable. Why? Because any value of x can be chosen randomly or independently. And then again, for y, we call y the dependent variable because the value of y depends on the value of x. Hence, however, y is called the dependent variable because the value of y depends on the value of x. Right. Now, in the activity, let's determine the value for y for the given value of x if y is equals to 2x minus 1. So now let's check how do we go about this one. The solution. For x is equals to negative 2, y will be equals to negative 5 because 2 times negative 2, it will be negative 4. And then negative 4 minus 1, it will be negative 5. For x is equals to negative 1, y will be equals to negative 3. For x is equals to 0, then y will be negative 1. And for x is equals to 1, y will be equals to 1. For x is 2, y will be 3. And then this is the table of ordered pairs, where we had negative 2 in the calculation. The value of y was negative 5. The corresponding value of y for x being negative 2 is negative 5. And then negative 1x, negative 3, y, and so forth. Right. So, and then we go to the next activity. In the next activity, we do the same thing. We substitute, we actually choose the values for x, and then we substitute on the equation. So where x is equals to negative 2, we will have negative from the equation into the value of x, which is negative 2, plus 2, which is on the equation, then the answer will give us 4. And then we do the same with the other values. Right, so they give us this table now. For negative 2 we had 4, for negative 1 we had 3, for 0 we had 2, for 1 we have 1, and for 2 and we have 0. Right, now we are coming to the real business of the day for grade 9, the quadratic equations. Now, this is new for grade 9. So now we have to look at what is going to happen when we are solving the quadratic equations. Right. The explanation. Quadratic equation is an equation of second degree. Remember linear, we said it is an equation of first degree, meaning the highest exponent of the variable in quadratic equation will be or are 2, because it might happen we have two variables at the same time. So the highest must be 2. Right, it is in the form ax squared plus bx plus c. That's quadratic equation. Right, and then quadratic equations have two solutions except when it is a perfect square trinomial. Like for instance, if we are having x squared minus 2x plus 1 is equals to 0. Right, now you will realize that before we do this equations for grade 9, we start with algebraic expressions. Algebraic expressions in grade 9 focus mainly on factorizing. So even the equations for grade 9, they will be focusing on factorization. So I should think we are familiar with factorizing quadratic equations, but nevertheless, we are going to go through that factorization. Right. For us to factorize x squared minus 2x plus 1, firstly, we must have the factors of x squared that are the same. So the factors of x squared that are the same will be x multiplied by x. Right. And then x multiplied by x will give us x squared. And then we must also have the factors of the last term. The last term is 1. So the factors of 1, the factors of 1 is only 1. So for us to get 1, we must, with similar factors, it will be 1 multiplied by 1, which will still be 1. But now look at what is happening about the signs. Remember, for us to have positive, when we multiply, we must multiply negative by negative or positive by positive. So in this case, we must have only one situation, either both signs being negative or both signs being positive. So in this case, we have to look again the sign of the middle term. The sign of the middle term will indicate to us to say, no, we must use negative, both signs being negative or both signs being positive. So in this situation, both signs must be negative because the middle term is negative. I would like to repeat this one. For us to have a positive when we multiply, we are having two situations. The one will be multiplying positive by positive or multiplying negative by negative. So now, only one situation is going to fit on that particular question. So in this instance, we'll have to look again. We'll have to relate the sign of the last term with the sign of the middle term. If the sign of the middle term is negative, it simply means both signs will be negative. If the sign of the middle term is positive, it simply means the sign of both terms of the last term will be positive. So in this instance, both signs will be negative. Now, as we can look, we are having x minus 1, x minus 1. So it simply means we are having two similar factors. So if we write them in exponential form, we will have x minus 1 squared because we are having x minus 1, and we multiply. Right. Now, the factors of x minus 1 x minus 1 will be equated to 0. And as they are equated to 0, then now the equations becomes linear equations. So for linear equations, we'll have to add positive 1 on both sides for the first one, so that we isolate x. For the second factor, we will have to add positive 1 so as to isolate x. So whatever that we do on the left hand side, it must also be done on the right hand side in order to balance the equation. So this is the situation. We cannot say x is equals to 1 and x is equals to 1, because 1 is one thing, x will be equals to 1. So it is with this situation whereby we are just only going to have one solution. But in other situations, we'll always be having two solutions. Right. While on quadratic equation, let's have a look at steps to solve quadratic equations. One, right hand side or left hand side must be equal to 0. So in other words, if there is anything on both sides which is not equivalent to 0, at least one side must be made to be 0 by just adding the same thing on that side in order to get rid of that side. In fact, with the opposite sign. Right. Secondly, we need to check if the expression is already in the form of vectors. If so, we just equate those vectors to 0 and then we solve. If not, we need to factorize the expression. So I just want to emphasize this one. We need to check first if the expression is already in the form of vectors. If so, equate each vector to 0. Like for instance, let's have a look at this now. Let's have a look at this. Right, let me say we are having x plus 3 into x minus 2. X plus 3 into x minus 2 is equals to 0. The equation is already in the form of the vectors. And again, the right hand side is already 0. So all that we need to do is just to equate x plus 3 to 0 or to equate x minus 2 to 0. Right, you will see during the presentation why must we equate these vectors, one of the vectors, to 0. You'll see, I will explain it. And then that's basically what you need to do if you are already having the vectors. But if you are not having the vectors already, in other words, the question will be like this: x squared plus 1, in fact plus x and then minus 6 is equals to 0. It is a pure trinomial, so it needs to be factorized. So we know how to factorize trinomial from algebraic expressions. But nonetheless, let's have a look at this. For us to factorize this trinomial, firstly we must have the factors of x squared, which are x multiplied by x. We must also have the factors of, so in other words, one factor of x squared will be on on another bracket, pair of brackets, and then the other will be on another pair of brackets. And then secondly, we must have the factors of 6, the factors of 6. So the factors of 6 in pairs will be 1 multiplied by 6, will be 2 multiplied by 3. They will give us 6. Now, the second step, we will have to look at the sign of the last term. The sign of the last term is a negative. That simply means the factors that we are going to get, we are going to subtract them in order to get the coefficient of the middle term, of which in this case the coefficient of the middle term will be positive 1. So now let's have a look at those factors, pair of factors that will give us positive 1 when we subtract them. So if you check at 1 and 6, if you subtract 1 from 6, we are just going to get 5. 6 minus 1, we are just going to get 5. So it means they don't give us the coefficient of the middle term, which is x, which is 1. Right, now this pair cannot be used. Now we are left with the pair 2 multiplied by 3. So for 2 multiplied by 3, 3 minus 2 will give us 1, which is the coefficient of middle term x. Now, it means the correct combination is 2 and 3. So therefore, one factor will be on the first pair of bracket, and then another factor will be on the second pair of brackets. Whether you start with 2 or you start with 3, it doesn't matter as long as the coefficient of x squared is 1. By the way, for grade 9, the coefficient must be 1, but if the coefficient of x squared is more than 1, it must be a common factor. Right, now we are having the factors. The challenge will be for us to get negative, we must multiply negative by negative. Negative by positive. Or we must multiply positive by negative. So in this instance, we must ensure that the bigger factor, not the bigger number, but the bigger factor of 6 must be assigned the sign of the middle term. So the bigger factor between 2 and 3 is 3. So therefore, 3 must be assigned the sign of the middle term. In this case, the sign of the middle term is positive. So 3 will be positive and then 2 will be negative. That's how you factorize. You basically factorize a trinomial. But the issue here is we must solve the quadratic equations. Now we must identify whether they are in the form of factors or not. If they are in the form of factors, we know what to do. If they are not in the form of factors, again we know we have to factorize. Right, then let's go back to our presentation. Right, and then we still continue with steps to solve quadratic equations. Right, when factorizing, look for the common factor first. If any in the form of a number, take it out. If it is only 2, you just take it out. If it is only 3, 5, you just take it out. And you divide both sides by that factor. Right, if common factor contains variable, what we need to do is to equate the factors first, and for that factor that contain variable is then that you can divide by the coefficient of a variable. You don't divide by the whole common factor. No, you'll understand why. Let's have a look at this point. In quadratic equation, it is important to know that if x multiplied by y is equals to 0, one of the factors will be 0, or both of the factors will be 0. In this case, x multiplied by y is equals to 0. It means both factors, they equals to 0. But again, we can have only one factor being 0. That is why we are having this statement to say x is equals to 0 or y is equals to 0. Look what is happening. If x is equals to 0, anything multiplied by 0 will be 0. So it will still give us the right-hand side. If y is equals to 0, x multiplied by 0 will still be 0. Hence, one of the factors must be 0. Right. Now, the point that I raised earlier, note that when solving equations, don't divide by the variable, because we don't know the value of the variable, and it might turn out that the value of that variable is 0. And what is happening when we divide by 0? You know, we are not allowed to divide by 0. Right. Now let's have a look at this example now. We are having x plus 2, x minus 3 is equals to 0. Already it is in the form of factors. So if it is in the form of factors, that simply means x plus 2 will be 0 or x minus 3 will be 0. And then it is now a linear equation. We can add negative 2 on both sides. Therefore, 2 minus 2 will be 0 for left-hand side, and then 0 minus 2 will be negative 2. For the second one, we can add positive 3 on both sides. Negative 3 plus 3 will give us 0, and 0 plus 3 will give us 3. Hence, x is equals to negative 2 or x is equals to 3. Right. And then example 2, solve for x. X into x plus 1 is equals to 0. Again, it is in the form of factors because it is x the factor and x plus 1 the factor. Right. Now, to solve it, either x will be 0 or x plus 1 will be 0. Right. So therefore, x will be 0 or x will be negative 1. One thing that I forgotten to raise is that, remember, when dealing with equations, left-hand side must be equals to the right-hand side. Whenever we substitute by whatever solution, it must give us the correct answer. If you substitute by 0 for x, it will be 0 into 0 plus 1. So any number multiplied by 0 will be 0. So it means it will be 1 multiplied by 0. If we substitute by negative 1, it will be negative 1 plus 1. Negative 1 plus 1 will give us 0, and 0 multiplied by x will still be 0. Right. Now, the second example now. It is not in the form of factors. What must we do now? Firstly, we must factorize. So we took 2 as a common factor. Because 2 doesn't have any variable with it, now we are allowed to divide throughout by 2. So we are only left with x squared minus 4. Then we'll have to factorize x squared minus 4. You'll realize that x squared minus 4 is difference of 2 squares. So on factorizing difference of 2 squares, this is what we do. X minus 4, no, it will be x minus 2. I'm sorry for the mistake. It must be x minus 2, right? Okay. Right, let's have a look at this. We are having x squared minus 4 is equals to 0. And then factorizing this, it will be x minus 2x plus 4. X plus 2. will be equals to 0. Therefore, x will be equals to 2, or x will be equals to negative 2. Right. So in the presentation, I didn't actually determine the factors of 4. I left 4 as it is, so which is actually wrong. Right. And then, so in other words, for this one, it will be x is equals to 2, or x is equals to negative 2. So for 4, it will be 2, it will be 2. Right. Now go into example 4 now. 3x squared is equals to negative 12x. Now for this one, you will realize we don't have any side which is 0. Then we will have to apply the additive inverse to move one of the terms to either side. Right. Now the solution, you will realize that 3x squared plus 12 is equals to 0. We actually added we added positive 12x on both sides. So as we added 12x on both sides, it must be 3x squared plus 12x. Another mistake there, but let's have a look at this one. This will be 3x squared is equals to negative 12x, and then all this, okay? So in other words, the solution there, it will be 3x squared plus 12x will be equals to 0. And then taking 3x as common factor, we are going to have 3x into, we are going to have left with x plus 12x. If you take out 3x into 12 as common factor, we are going to left with 4, which will be equals to 0. Now remember the situation that I've raised, that we cannot divide throughout by 3x because we don't know the value of x. Therefore, it will be 3x is equals to 0, or x plus 4 will be equals to 0. Therefore, x will be equals to 0, or x will be equals to negative 4. Right. So it was supposed to be 3x into x plus 4 is equals to 0. And then 3x is equals to 0, or x plus 4 is equals to 0. Then x is equals to 0, or x is equals to negative 4. Right. Now go into the activities. I'm not going to dwell much on the activities. As you can see, this one already in the form of brackets. It is already in the form of brackets. That's x minus 7, x minus 10 is equals to 0. Right, and then x minus 7, x minus 10 is equals to 0. Therefore, x will be equals to 7, or x will be equals to 10 for this one, because we said x minus 7 will be 0, x minus 10 will be 0. Right, and then the activity will just go just like the examples. Here it will be the issue of equating x to 0 and x plus 5 to 0. Right, and then this one, it is the one that we must be careful not to divide by 6x. Right, and then we have to move 9 to the left hand side for this one, and then this one, that is the one that we need to factorize. Let me just quickly do this one. That is x squared. I think that is the last activity. 4x minus 12 will be 0, and then Right. So in other words, we'll have to factorize this. The factors of x squared will be x and x. The factors of 12, that will give us negative 4. It will be the factors of 12 that will give 4. It will be 6 and 2. And then the larger factor will take the sign of the middle term, which will be negative, and the smaller one will be positive. Therefore, x minus 6 will be equals to 0, or x plus 2 will be equals to 0. Then the answer will be x is equals to 6, or x will be equals to negative 2. Right. Right. On conclusion, please take note that we actually dealt with the baseline from grade 8, and then for grade 9, it's only this part for the equations. So thank you very much for your time, and hope this lesson will help you if you have been struggling with the algebraic equations. So thank you very much, and hope I will see you next time. Thank you very much.